Hey everybody, it's Mr. Carr again. Today we're going to continue our work with arithmetic sequences. We're going to be talking about specific sums. Okay, sums of n terms of an arithmetic series. Okay, so what that means is it's going to be the sum of the first 10 terms of a series, or what is the sum going from the fifth to the 20th sum, something like that. So we have two formulas that we can use for this. So this is the sum of a finite arithmetic series with n terms, or the nth partial sum of an arithmetic series, can be found using one of these two related formulas. Okay, so we got n, we got a sub 1 and a sub n. This formula you would use if you know, what a sub 1 is equal to, you know what, let's say a sub 44 is equal to, and then you know that n is 44. So you know these three pieces of information. So you can plug it into the formula and work with that. The other formula is basically rewriting a sub n as something in terms of a sub 1. That's what this is happening here. So for example, since a sub n is equal to a sub 1 plus n minus 1 times d, then I can take this and plug it in here, and that's what's going to come out with this. So what's nice about the second formula is that if you know the number of terms and you know the first term, that's all you need. You don't need to have this information here. So you can plug it into this formula just like this. Okay, so that's where the second formula comes from. So let's look at an example of that. So find the sum of this arithmetic series. Here's the thing. In this case, we know what a sub n is. We know what a sub 1 is, but we don't know how many terms it takes to get there. So we want to model this using our explicit rule to figure out the number of terms. So if I look at this, we know that the common difference here is going to be adding 5 every time. Okay, so we know that's adding 5. We know it ends at 157, starts at -3. So if I use my explicit rule, so a sub n is equal to a sub 1 plus n minus 1 times d, we can set this up with all the information we have. So 157, -3 will go here, n minus 1 times 5. Now we're just going to solve this through algebraic processes to find the value of n. So we can add 3 to both sides. So 160 is equal to n minus 1 times 5. If I want to, I could distribute the 5 out, but personally, I like to just divide 5 here. So that's going to give me 32. I'm doing that correctly. 160 divided by 5. Yep, 32. And that's going to equal to n minus 1. And then my final step here is to add 1. So that tells me 33 for n. So what that means, this is actually a sub 33. This is the 33rd term in the sequence, is 157. Now that I know the number of terms, I could find the sum of all the numbers going from here to here. That's what this formula is going to be used for. We have everything we need for that formula. So the sum of the 33 terms will equal to 33 divided by 2, multiplied by the first term plus the last term. Again, we had to figure out how many terms this was to make this formula work. Okay, so that's going to be 33 over 2 multiplied by 154. So I'll just put that in the calculator. 33 over 2 times 154 gives us the sum of those 33 terms is going to be 2,541. Okay, so with these sums, we're basically interpreting these, making sure we have all the information we need in order to fill in these formulas. Okay, so that's what our goal is going forward. So find the 17th partial sum of the arithmetic series. So it says here 17th, so we know we're going all the way up to a sub 17. We have the first term, a sub 1 is 53. And then we look at our pattern here. So I got 31 minus 53 is giving me a -22. That's my common difference. Now, when I set this one up, I could try to figure out what is a sub 17 to figure out what this formula is. But with the second formula, I've got everything I need. Okay. So if I want the partial sum of the 17 terms, that is going to be n divided by 2. So it'll be 17 divided by 2 multiplied by 2 times 53 plus 17 minus 1 times a -22. So there's a lot going on here. If you're doing this in a calculator, you could just do this all in one step. Just make sure you keep like parentheses everywhere that we have them here. That'll keep everything in order, but otherwise you just got to do your normal order of operations. So I'm going to keep the 17 over 2 on the outside for now. I got multiplication here, subtraction, and multiplication there. So I'm going to do the subtraction first to 16. Now I've got 16 times negative 22 and 2 times 53. So I have 106 plus 16 times the negative 22 gives me negative 352. So the sum of these 17 terms will be 17 over 2 times negative 246. So I multiply that out, and I get negative 2091 for the sum of those first 17 terms in this sequence. Okay. So we can also apply this with our summation, our sigma notation. So when we look at this pattern here, this is an arithmetic pattern. Every value is going to be added by 6. So that is telling me that, well, and I should say, so we're adding 6 here, but what I'm really looking at is that this is like a 1n. So what I can do in this case, there's two things I can do. The one thing you can do is you can just do the summation. You got your calculator, we can go back to that. We'll show that how that works here. But applying it to my formulas, there's a sequence of numbers where I start at the 10th term and I get up to the 32nd term. So I have enough to say this one. How I'm going to make that work is I want to know what is the 10th term. So I'm going to plug it in when n equals 10. Okay, so when n equals 10, we're going to have 10 plus 6, which is 16. When we go up to the upper limit, n equals 32, then I'm going to have 32 plus 6, which is 38. So we know the beginning of this partial series and then the end of it. So we have this information, this information. We now just need to know the number of terms in between. This is where it's going to be a little bit tricky. So we want to count the number of terms from the 10th one up to the 32nd one. A lot of people would just say, well, just subtract the two numbers. And that's close. Think of it this way. Let's say I subtract 9 from this and I get it down to the first term. To find that spacing, I subtract 9 from this. That gets me down to 23. So from 1 to 23, there's 23 terms. Same exact thing with 10 to 32. So I want the number of terms. I'm actually going to take 32 minus 10 plus 1. And that's another way I can get to 23. So, so now we have our number of terms. We have our first term and our last term. So I can go ahead and find that. So the sum of the 23 terms here is 23 divided by 2 multiplied by 16 plus 38. So the sum of the 23 terms is 23 over 2 times 54. Okay, so I multiply those out, 3 over 2, and then I get 621. Again, you didn't need to do this, but I want you to see how this relates to our arithmetic series, okay? So when I go back to, we'll go to Desmos here, and I can evaluate this summation in that. Okay, so I go to functions, go down until I get my sum. Okay, n was starting at 10, it goes up to 32. And my rule here was n plus 6. And you see it gets the same exact answer, 621. Okay, so just two tools you can use to help with this. Again, it depends on the fact that it's an arithmetic sequence here. Let's look at some word problems now that are examples of arithmetic series. An artist receives royalties for all CDs of his music that are sold. The first 10,000 CDs, the artist receives $10,000. For the next 12,000, he receives 12,500 for the next 10,000, and then 15,000 for the next 10,000 after that, and so on. So how much money will he receive if there are 500,000 of his CDs are sold? It's a little bit tricky on here, but we actually have enough to tell us this. First thing is, I want to know where we're starting at, okay? The first term is basically going to be this $10,000, okay? The last term, how much money? So the last term is going to be this a sub n, but we need to figure out how many terms, like how much money he gets at that last 10,000 group. So the idea behind this is I can figure out my number of terms by taking 500,000 divided by 10,000, because it's every 10,000 CDs. Every 10,000 CDs he sells is going to be like another jump up to the next term. Okay. So if I do that, we can just cancel all that out. So that's going to be 50 terms. Okay. So now, well, actually, I don't want to use the first formula because I don't actually know. So I guess I shouldn't use this formula because I don't know what the a sub n is. I could figure it out with the explicit rule, but I'm just going to go ahead and jump to this one now because I have a sub 1, which is that 10,000 up here, $10,000. Whoops, that's $10,000. We now know the number of terms, which is 50. So that's going to go there and there. And my common difference. If you look at this one, it's going from 10,000 to 12,500 to 15,000. So that common difference is $2,500. So the sum of these 50 terms is equal to 50 over 2 multiplied by 2 times the 10,000 plus 50 minus 1 times 2,500. Okay, so we're just going to go through and work through that to simplify that one. So that's going to be, I'll put 25 in the front. We have 49 times the 2,500, and then 2 times the 10,000, give me 20,000 here, plus the 49 times 2,500 gives me 122,500. Okay, so I'll add that with the 20,000. We have 25 times 142,500. So we multiply that by 25 and I get $3,562,500. So this will be the total amount of money that the person received by selling 500,000 CDs. Okay. So again, this was receiving it in chunks of 10,000, then 12,500, and so on and so on. Okay. So now we can, let's look at, let's say one more. Yeah, one more version of this. Okay. A lot of the similar ideas. We're looking for through and analyzing for the number of terms, the first term, the last term, things like that. Anna sells clothing in a store at a mall. Her commission on the sale of new seasonal merchandise is $3.50 per item. That's costing at least $25. To encourage an increase in sales, the store manager promises a 5-cent increase in commission for each additional item sold. So thus, on the next item, she'll earn $3.55. Third item, she's going to get 5 cents more than that. How many items worth $25 or more will Anna need to sell for her total commission on new merchandise to be at least $1,000? Okay, and that's the total commission. So that means, again, we're talking about a sum here. So in this scenario, we can see that the common difference, how much money she earns each time, that's going to be the 5 cents each time. The first term is her first commission, which is at $3.50. Okay, so if we want our total commission to be at least $1,000, this is actually going to be my S of n. Okay, so we're looking for the number of items. So we're actually going to use this formula once again, but now I want to solve for n in this case. So $1,000 is going to go right here for the S of n, and we're going to use this to help solve for n. Okay, so let's set that up. $1,000 is equal to n over 2 times 2 times a sub 1, which will be $3.50, plus n minus 1 times 0.05. Okay, so I don't like having that fraction out front. Might as well, we're going to multiply both sides by 2 here. That way that cancels that out. So I'll have 2,000 is equal to, we'll have n multiplied by, this will be 2 times 350 is going to be 7. And this will be, well, we can distribute this out here. So that's going to be 0.05n minus 0.5. Okay. All right, so then we can combine our like terms here with these two. So I'll have 2,000 is equal to n times 6.5 plus 0.05n. Okay, from here I can distribute. So I have 2,000 is equal to 6.5n plus 0.05n squared. And one last thing I can do, because it's now a quadratic to solve, let's get this equal to 0. So I'm just going to rearrange it a little bit as well as 0.05n squared plus 6.5n minus 2,000. And if you're solving by factoring or anything, you're going to want to turn this into a 1 in front, so you can multiply everything by the same number to make that into an easier number to work with. Or we just put it in our calculators with quadratic formula or anything like that. So I'm just going to pause it real quick so I can get that set up and we can get the final answer here. Very sorry about that. I just realized I made a mistake earlier, so let me go back and fix that. Up here, when I did the distribution of 0.05 to both of these, I wrote it as 0.5. That's my fault there. It should be a 0.05. Now I combine that with the 7, and that'd be 6.95, which changes that down here. So it's going to be 6.95, 6.95 as well. Very sorry about that one. So again, I'm still going to do quadratic formula for this. I'm going to solve it out. When you do, you're going to get 2 answers. Remember what n is representing in this case. N is representing the number of items here that she's going to sell. So I'm going to get a decimal number of 142.23. I don't care about the negative number. The negative number is not realistic here. So my negative answer doesn't matter. So to answer this, fully answer this in context, because that's a decimal number that's representing the number of items sold, that part by itself is not realistic. So she has to sell at least 143 items to earn a commission of at least $1,000. Okay, so that's it for today. We're just looking at that, using these 2 formulas right here when we use these to help us find the sum of a series in an arithmetic sequence. Okay, so depends on what information we have. We can also apply them to these word problems. We're looking for things like first term, last term, the number of terms, the common difference. Those are the piece of information that will help us in these 2 formulas. All right, that's it for today. Take care, everybody.